Hey everybody, I hope you are doing great. We're going to get into 4-2 here today. We're going to keep on with writing some stuff. We're going to look at some new forms as well. So we're familiar with standard form. We are familiar with slope intercept form. Today we're going to learn a new form. It actually happens to be one that we've kind of seen before, but we've never really talked about it. We saw it in one of our Desmos activities, right? And it had a weird number out front and then some parentheses and some other stuff. So anyway, that's going to come back today, and we're going to see that. But just in case you forget, so standard form, guys, here's what our standard form looks like. Here, make this a little bit bigger, and do that. So standard form, this is our ax plus by equals c. This just says x and y are on the left side, or one side, it could be the right, and your constant is on the other side, okay? So it might look like negative 2x minus 4y equals 1/2. That would be standard form. All right, point slope. As the name indicates, it's going to have a point and a slope in it, right, when it's all said and done. So point slope form looks like this. Y minus y1 equals mx minus x1. Okay? That is our, like, y equals mx plus b. So, guys, m we should recognize, right, as slope. X and y, those are just my x and y variables, right? Like we know them in y equals mx plus b. Like we know them in ax plus by equals c. Okay? Those are just my x and y variables. Y1 and x1, well, that is the point, right, an ordered pair. That's why we call this point slope, okay? So we have a point and we have a slope, right? And then we can figure some stuff out. Okay, so let's write some equations, guys, in these two different forms. It should be a lot of fun. Again, here it goes talking about standard form. That's great. And here we go. Okay. We're planning a party. Party favors cost $6 each. Balloons cost $4.50. You have $90 to spend. Okie dokie. Write an equation in standard form that models the number of party favors and balloons you could buy. So those are my two variables, right? Party favors, balloons, right? So standard forms, our two variables are on the same side. And this is the way we're going to write this equation, right? I don't know how many of each I bought, but I know party favors are $6 a piece, okay? So I'm going to say, hey, $6 times some amount of party favors is how much I spent. I also bought balloons that cost $4.50 each. Again, I bought some amount of balloons. I will call them Y, okay? And we spent $90. So again, these two amounts equals $90. Okay? Bam, there we go. I'm not going to graph it. Again, guys, we can literally just put this right into Desmos, right? And we will get a beautiful graph for this one. Okay? You guys good with that? Again, look, if you wanted a quick one, right, it's going to look something like this. There you go. It's graphed. Right? I'm more concerned with let's write it. Yes, make all of this go away. Okay. If you could buy 9 party favors, how many balloons could you buy? So we got to use that equation. I'm mad I shouldn't have gotten rid of it. Actually, maybe, can I make it come back? Yes, look at that. Hot dog. Okay. All right. Let's get rid of some stuff here. So if we have 9 party favors, okay, we got to remember who is which variable. So party favors were $6 each. Okay, how many balloons could we buy? So you bought 9 party favors. How many balloons could we buy if we spent exactly $90? So guys, I just want to replace, right, x with 9 and solve this. So 6 times 9 plus 450y equals 90. Okay, here, I got to get this out of the way now. So guys, we're just going to go ahead, right, and we're going to solve this equation. This becomes 54. Okay, this is still 450. This is 90. Go ahead and do some subtracting on here. So Yeah, we can solve for y, so move this over. And 450y equals, what is this, 36? I think if that's not right, somebody's got to tell me. And then last step, guys, just divide by your coefficient, right? And we should get, actually a good number here. We get 8. Okay, again, what does 8 represent? Well, that represents how many balloons we could get, okay, if we spent exactly $90. Okay. Moving on, so standard form seems quite fun. Here comes point slope form. Again, we haven't seen this one yet, so I'll slow down a little bit for us. Right, here's that weird equation I wrote earlier. Y minus y1 equals m times the quantity x minus x1. Again, y1 and x1 are the point or an ordered pair on the line. M is the slope of the line. We put it all together and we can generate an equation for it, okay? And if you notice, guys, we will know, or we should be able to see a pattern of, hey, I can identify that's the slope, and then there's the ordered pair of the point on the line that it's going to go through, okay? Okay, here we go. Write an equation in point slope form for the line that passes through this point, okay, with a slope of -3/2. Okay, I think we can do this. Yeah, we'll do the shortcut way at the end, okay? Somebody remind me about that. So here we go. Y minus y1 equals slope m x minus x1, okay? Plug in what we know. Look, here is an ordered pair. That ordered pair has my x1 and y1 in it. Here is a slope, m. Replace what we know. Leave x and y exactly where they are. So this is going to look like y minus 0 equals -3/2 x minus, be careful here, -2. Okay, we're subtracting, and it's -2. So, guys, we need to simplify this right now. So x minus -2 is the same as just x plus 2. All right, so we're going to clean that up and say x plus 2. Okay, y minus 0. You know, normally, guys, you'll see we're going to move this to the other side, but for right now, we're not. And so we're just going to say, hey, y equals -3/2 x plus 2. Okay, and there you go. That's point slope form because I can easily identify right now what the slope is, -3/2. And now we can also identify a point on the line. Now this one's a little bit confusing because we had a 0, and normally we would add or subtract that 0 over here. And we would put it out here. And that is how I would know that point, okay? But in this case, it's 0, right? It's there, but it's not there, okay? So, again, notice it went through the point -2, 0, but this is kind of like the opposite. Well, that happens because we're subtracting, and we end up with double negatives, okay? But guys, when they say write it in point slope form, here you go. Bam, you stop right there. We're good to go. Okay? Hopefully we get to do another one of these. Oh, was I supposed to graph that one? Yeah, graph it. Again, guys, we could graph it on Desmos. I'm not worried about that. I'm more worried about us understanding and writing these correctly. Write the point slope form of an equation for a line that goes through this point. There it is over there. With a slope of -2. Okay? Y minus y1 equals m x minus x1. If we're going to use a formula, guys, we got to write it out, and then let's plug in what we know. Okay? I know that 4 is an x value, right? This is my x1. It's going to go here. -3 is my y1. It's going to go here. My slope of -2 is going to replace m. Okay? We're going to get double negatives, and that's okay. Watch what happens. So y minus -3, okay, equals my slope, -2, x minus 4. Okay. So guys, really, y minus negative 3, double negative is the same as just saying x plus 3. Okay? Now, to put this in point slope form, I need to move that 3 over here. I'm not going to distribute this just yet. Okay? Eventually, we'll get to this, right? Subtract 3. Can I just subtract negative 4 minus 3 and call that negative 7? No, because think about it. These two things are held together with multiplication right now. So you cannot do that. So y equals negative 2 times the quantity x minus 4 and then minus 3. So guys, here you go. Okay? This is point slope right here, right? Now we're getting somewhere. I know the slope, 2, and then here's my point. Right? Think about this. I've got negative 4, negative 3. Right? Here was the ordered pair they gave me originally. It was 4 and negative 3. Okay? Think about our left-right moves, guys. If I just said x minus 4 is in parentheses, is that a left move? Is that a right move? Well, we would normally think left 4, but no, because that's negative. So it really moves right 4. And look, that's where our x is on this one. It's at positive 4. So we always just take the opposite of this number and then this number as it is, positive or negative, and that's your ordered pair, x, comma, y. So 4, comma, negative 3, and look, that's the point we ended up here. Eventually, some of you will be good enough where you can take this ordered pair, take the opposite of that number, put it in this parenthesis, take your slope, put it here, take your y value just as it is, and put it here. When we get that far, right, and as we do more of these, you'll probably get more comfortable. For now, let's just work our way through the steps, okay? Which, again, really, it's not bad at all, okay? Again, if we would graph it, it's going to look like that over there, okay? Nope. Write an equation in point slope. Whoa. Slope-intercept and standard form. Wowzers. Okay. This is where point slope comes through in the clutch for us, okay? This is where this one is great. Okay. Come on. They didn't give me slope on this one. Okay, so guys, step number 1, we need to find slope. So this shouldn't be challenging for us. y2 minus y1, okay? x2 minus x1. So negative 7 minus 5 is negative 12. 6 minus 3, I can't even, whoa, yeah, that's good. We can't even get a good one here. Okay, so simplify this down 4/3. Okay? You guys good with that? Hopefully you are, because I'm good with it. All right, so we know now the slope is 4/3. And I just need to now write 3 equations that all look different but show the same line. And that's why we have standard form and point slope form and slope intercept form. Okay, so we're going to see 3 different versions of this. So let's go with the first one, point slope. Y minus y1 equals m. Now, you're probably asking yourself, well, which ordered pair do I use? I see 2 of them here. Doesn't matter. I would choose the one that doesn't have negative numbers in it if it was me, right? Negative numbers in point slope, guys, lead to double negatives, and that can confuse some of us, or we might make a careless mistake, okay? So y1 is that 5. So y minus 5 equals my slope, 4/3 of x minus 3, okay? Just one step to get it into point slope, and that's move 5 over here, right? So y equals 4/3 x, sorry, that's x minus 3, and then plus 5. Okay? Bam. Stop right there. There is point slope done. Okay? You'll find point slope is very similar looking to slope intercept. Right? If I were to distribute 4/3 in here, guys, I think some interesting things would happen. So let's do that, okay? So here is one of my answers, okay? So this is point slope, okay? Now, to get this in slope-intercept, guys, I'm just going to distribute 4/3. So y equals 4/3 x minus 4 plus 5. Okay? Let's just go ahead and simplify this right now. So what's negative 4 plus 5? That is just plus 1, right? Here is, no. Here is slope-intercept form, right? Isn't this slope-intercept form, right? 4/3 is your slope, 1 is your y-intercept. Okay? This is pretty close to standard form, right? Standard form says, hey, bring x and y back together. Now, standard form hates fractions. I mean, hates them. So we have to get rid of this fraction, okay? So y equals 4/3 x plus 1. So the very first step to get rid of a fraction, multiply by the denominator. But you have to remember, everybody gets multiplied by this denominator of 3, okay? So I'm going to multiply the y by 3. I'm multiplying here by 3. And I'm also multiplying the 1 by 3. Okay? All right. So 3y equals, well, 4/3 x times 3. Well, that just makes this 4x. Okay? 1 times 3 is just 3. And now we are almost done. Now it's just move x and y together. So we're going to subtract 4x. So I'm going to write x first. So negative 4x plus 3y equals 3. And there you go, guys. There's our 3 forms, okay? Here is, let's do that. So here is our first one, point slope. Here's our second one, slope intercept. And then here's my last one, all right, in standard form. Doesn't matter. If you were to graph all 3 of those on Desmos, they will show you the same graph, right? It's going to go through 1 on the y-axis, right? It's going to have positive slope. Okay. All right. So I think we did everything we can there. No, gotta go here. What is going on? It's like it doesn't want to fast forward, my friends. Oh no. Well, hold on. We can fix this. There you go. Okay. So guys, we got a trapezoid here. Look, I'm back. Here I am. Woo! Okay. Trapezoid. Write an equation in point slope form for the line containing BC. Okay, so BC, guys, is this side right here, right? So there you go. All right. So first things first, find slope of this line. So we've got the ordered pair 4, 3, and the ordered pair 6, negative 2. So go ahead and find slope. So I'm going to go 3 minus negative 2 plus, this will turn into 5, and this will be 4 minus 6, which is negative 2. Yeah, there's my slope, negative 5 halves. Okay? Yeah, it's not a great slope, but it is what it is. Okay, so I'm going to clear all this out. Yes, I know I subtracted in the backwards order, folks. Good news, right? It still gives me the same slope. Okay? Little known secret. Well, it's not little known anymore. Now it's out there. It wants my equation in point slope form, guys. Pick one of the ordered pairs. I like positive numbers, so I'm going to stick with 4, 3. Okay? So y minus y1 equals slope times the quantity x minus x1. Plug in what you know. Right? If you think you want to try to, hey, I want to try to do that whole point thing where I take 4, 3, we're going to take the opposite of this, and we're going to put the 3 over there, and put this. You do that. And then let's compare it to see what we get here. For the rest of us, we're going to go y minus 3 equals negative 5 halves times the quantity x minus 4. And then my last step is just to move that 3 over there, right? We don't need to distribute. So y minus negative 5 halves times x minus 4 plus 3. Okay? And there you have it. So it's in point slope, right? The point that this line will go through is the opposite of this, 4, comma 3, and it has a slope of negative 5 halves. And that's what that line, you can't really see it too well, but that's what that line right there has. Okay? I don't know if we, yes, we can move. Fantastic. All right. Bam. Write an equation in standard form for the same line. Why do I always do this? Okay, so here you go. So standard form. Okay. So again, I'm in point slope now. So if we're going to go standard form, guys, we need to go through slope-intercept form in order to get there. So the very first thing I want to do is distribute, right, negative 5 halves into both of these. Ooh, boy. Okay. So negative 5 halves. This is going to turn a negative times a negative into a positive. That's going to be 20 over 2, which is the number 10. Okay. We'll add 10 and 3 together right now to say 13. And now we have to get rid of the fraction. So it's negative 5 halves. So we're going to multiply all 3 terms by the number 2, right? Everybody's getting multiplied by 2. So 2 times y is 2y. 2 times negative 5 halves is just negative 5. And 2 times 13 is 26. Okay? It's as simple now to move that 5x over with y, so we're going to add it to both sides. No, it does not combine with y. And there we go. Okay? 5x plus 2y equals 26. Is there a way to check to see if this is indeed the same? I would bring up my good friend Desmos, and I would put this graph in there. Okay, I'd see what it looks like. Then I would go back and I would put this point slope one in there. Do I get the same line, right? Are they identical? Do I only see one line on the graph? If so, then we know we did it right. Okay. Again, write the point slope form for the line that has our hypotenuse in the triangle AB. Again, AB, right, is the hypotenuse, that's the diagonal, the longest side of any triangle. So first step here, guys, is I have to figure out what is my slope. Okay? Slope on this one is 1, 2, 3, 1, 2, 3. The slope on this one, guys, is just 1. Okay? Again, if you don't believe me, we can go y2 minus y1 over x2 minus x1. I get 3 over 3, which is the number 1. Okay, so I have a slope of 1, and now I just need to pick one of these points. I'll do 6, 4. Right? Again, doesn't really matter. So we're going slope of 1, right? And we're going to use 6, 4, okay, as my ordered pair. All right. Y minus y1 equals slope times the quantity x minus x1. If you wanted to try to put everything in there, you could, right? I think it might be kind of fun, but in the meantime, just go y minus 4 equals my slope of 1. Now, the question is going to be, do I really need to write the slope in here? Yes, you do, because it's in point slope, guys. So, I mean, we kind of want to know that that 1 is really there, even though if we didn't write it, right, and it would be that invisible 1, okay, it would still be there, okay? I think it's best if we do write it. Okay, so we got that in there. Let's go ahead now, move this 4 over here, so we're going to add 4, right, x minus 6 plus 4. Again, here's my ordered pair, 6, negative 4, right? We see that come through as negative 6 and 4, right? That makes sense. Okay? I think that's all we had to do there. I wonder, is there anything else I have to do? Oh no, are we back to not working again? Should. Don't worry, I'll just go move it from back there. Give me 1 second. Oh, we can do this, guys. This is just standard form. Okay? So once again, we're going to take our equation that we just made. Here it was. And we're going to put it in standard form. All right, so here, I got to make some room. Oh no, nothing's working now. Maybe some things are working. Who's to say? Okay. So, y equals 1, x minus 6 plus 4. Okay. So guys, I'm going to go ahead and distribute the 1 combined like terms. That's the first thing I got to do here. So 1x minus 6 plus 4. We will combine negative 6 plus 4 to, that's right, negative 2. Okay? So this will turn into negative 2. Write this in standard form. So 1x needs to move over here with really 1y. Okay? So we'll subtract that. So negative 1x plus 1y equals negative 2. Again, other forms that we could write this. You could just say negative x plus y equals negative 2, right? That's like the fancy way to write it, but it means the same thing. You can leave those invisible coefficients out. So, okay, guys, I think that's good for 4-2, writing equations in our new form. So hopefully you enjoyed it. We should now be able to get into our book work and our quizzes and be ready for the homework, okay? Take care.